Thank you for your interest in Bharat AI SOC Student Challenge. This initiative, driven by ARM and ARM Education, aims to support skill development in India by encouraging students to tackle industry relevant problems and devise innovative and impactful solutions. We are proud to partner with Mighty C2S program as well as collaborate closely with IT Delhi, our lead academic institution in this endeavor. I extend my gratitude to Ministry of Electronics and IT as well as IT Delhi for their support in this exciting initiative. Good luck to all the participating teams.
Hello everyone, my name is Balivada Sri Charita and I am currently a master student at IIT Delhi. I am the program assistant for the Bharat AI SOC Student Challenge. In this video, I will explain the problem statement for the challenge titled Real-Time On-Device Speech Translation for ARM CPUs and walk you through the technical expectations and also highlight what we are really looking for in your solutions. The core problem you are being asked to solve is to build a fully local, real-time speech-to-speech translation system optimized for ARM-based CPUs. The pipeline starts with the spoken input in language A, performs on-device speech recognition, translates or semantically rewrites the text using an on-device language model, and finally synthesizes speech in language B. All processing must happen entirely on device without any cloud dependency. Important to note, while we provide a clear baseline problem definition, we are explicitly looking for novel and innovative solutions, not just straightforward implementations. Think of this as an open innovation problem where creativity in system design, optimization strategies, or user experience is strongly encouraged. The project objective is to demonstrate that high quality, real time AI pipelines can run fully on device within the constraints of mobile hardware. There are three key goals. ARM CPU optimization. You are expected to leverage SME2 wherever available or Neon or NPU support otherwise. Fully local operation, speech recognition, translation, and synthesis must all run on device. Real time performance. The system should meet conversational latency while remaining power and thermally efficient. That said, you are not constrained to only these approaches. As long as the mandatory requirements are met, you are free to explore additional techniques, optimizations, or architectural ideas. Let's look at the end-to-end pipeline you will be building. Stage 1 is to capture the audio. Continuous spoken audio input from the microphone. Stage 2 is speech to text. Convert speech into text using an on-device ASR model. And the stage 3 is to do an LLM-based translation or semantic rewriting. Translate or rewrite the text to ensure fluency and correctness. And stage 4 is to perform text to speech. Convert the translated text into natural sounding speech. This pipeline performs the minimum functional system. However, teams that go beyond this baseline by adding intelligent buffering, adaptive latency control, multilingual switching, personalization, or robust features will be especially appreciated. An ARM-based smartphone CPU is essential for this project. Devices supporting SME2 such as Oppo Find X9 or Vivo X300 are preferred but not mandatory. If SME2 is unavailable, Neon optimized CPUs or onboard NPUs are perfectly acceptable. Crucially, this challenge is not restrictive in terms of hardware. If you have access to additional sensors, accelerators, or experimental platforms and they help you improve the system, you are free to use them as long as the core requirements are satisfied. You will also need a microphone for audio input, a speaker or headphones for output. Now let's talk about the software stack and model choices. For speech to text, you may use lightweight ASR models such as Whisper Tiny. And for LLM translation, you can use compact on-device LLMs like Phi2 or Gemma 2B. For performing text to speech, Fast Speech 2 plus Hi-Fi GAN or BITS Lite are good choices. These are recommended baselines, not limitations. You are free to experiment with alternative models, hybrid pipelines, or custom optimizations as long as everything runs fully on device and meets performance constraints. Innovation in model compression, scheduling, or pipeline fusion will be viewed very positively. Now coming to the critical software mandates. There are three mandatory constraints. No cloud inference. All processing must be local and real time. Quantization is required. Use in4 or in-date wherever possible because this reduces the memory footprint. And you have to use an ARM specific optimization. So an SME2 would be preferred or Neon must be used. Beyond these mandates, you are not restricted. Additional libraries, frameworks, or optimization techniques are welcome, provided they do not violate these core rules. Performance matters just as much as correctness. We expect near real-time latency, efficient CPU utilization, energy-aware behavior, natural and intelligible speech output. Teams that demonstrate additional performance-aware features such as dynamic quality scaling, adaptive power modes, or latency-aware translation will stand out. Coming to the deliverables, your final submission should include a fully functional on-device pipeline, clear documentation of design choices, performance analysis, a working demo on an ARM device. Extra features beyond the basic requirements, if well justified and well implemented, will be highly appreciated and can significantly strengthen your submission. Coming to the learning outcomes, what you gain from this challenge. End-to-end AI system design experience, ARM-specific optimization skills, practical exposure to quantization and mobile inference, a strong understanding of edge AI constraints. More importantly, it gives you the freedom to build something novel and impactful, not just meet a checklist. To conclude, this challenge provides a solid baseline, but we strongly encourage you to think beyond it. Be creative, explore new ideas, and push the limits of what can be done on device. Have fun building, and we look forward to seeing your innovative solutions. For any questions, please contact techqueries@armbharatchallenge.com. Thank you and all the best.